Hello everyone. Hello Frank. Hello my friends, those who are watching us and have joined us. How's the life, Frank? Where are you right now? Tell us more.
I'm at an airport, just traveling back from the InfoBip Shift conference. I just arrived at the airport and then leaving from there. That's perfect.
Okay, Infobip, like folks, those who are watching us, have you been to the conference? If have anybody been there or heard about this conference, let us know because Frank, I've never been to this conference. I heard about it once, and Frank went there first time, and you are very excited. Why? What was excellent about
And
it?
first, I submitted because you told me that it would be a good idea, and actually, yeah, it was. It was the first time for me. I think I've never seen such conference with a big organization, a big venue. The venue is a sport arena. It's very big, and they have apparently a lot of budgets to organize
Mm-hmm.
everything. And the budget comes from the sponsors. So it's really nice today to see that many conferences are struggling to get sponsors, and here they have a lot. And
A
not
lot of
only
sponsors.
IT companies, for example, they asked a coffee company to sponsor, and then good coffee at conference. Perfect.
Coffee company, who else? Just let us tell us a bit more. What are the other
Uh,
well-known names?
Also, Porsche was sponsoring, and
Okay.
some people got the opportunity to test the car on a circuit. Yeah, that was very unique.
Okay, wonderful. So it's like it was in that sport arena where you can come and race a car, or
That was around in the sport arena.
I see.
The main stage was a 360 stage with all seats around, and then all around you had the corridors, the sponsor, other rooms. No, that was really nice. Yeah.
All right.
And
Yeah. Hello, Ashwar. Yeah, like folks, send us your welcomes. Send us how you're doing today, and also share your questions. Because just little break, right, Frank? Before we return back to your conference experience, this is our ninth episode of the Community Open Hours. The time is fleeing really fast, and we envision this live stream as an opportunity to show you something new or to show you tips and tricks, but also to answer your questions. So we don't need to follow the agenda precisely. If you have any question or problem that bothers you, think about it and write down in the comments, and we'll make sure to get it covered during the stream. Coming back to you, Frank, I know that you was talking about YugabyteDB. How was your talk perceived by the audience? How did they like it?
actually, I was talking about more generally microservices and database, because that's something that is not always easy.
Mm-hmm.
You want one database per microservice, but then you may have some problems. And then I explained, mainly my goal was to explain the SQL features that helps to isolate microservices within a single database. And with distributed SQL, we have even more features. The most simple is that you don't need to segregate into multiple microservices for high availability, because anyway, the database is always available and resilient.
Okay, that's a good topic, and I
Uh,
so
and and then
probably
and, and
this is
then
what we
I
need to discuss, man. This is what we need to schedule for one of our future episodes because microservices, and there is
yeah.
always a kind of a debate, uh, especially there is no any silver bullet solution, but like if you have multiple microservices, should you use one single database instance or should you have separate database instances, and what are the implications? Did you cover that as well? And hello, Zayan. If sorry if I mispronounce your name. Welcome to the show, and make sure to ask us and challenge us with the questions and that you might have.
And yeah, about the discussions I had after, of course, because I was talking and explaining Yugabytes, then I got, yeah, people interested because they run on Postgres, and because not only about the scalability, but simply they run on Postgres. They have some problems with the vacuum, with all that, and are interested to see a new storage engine that is compatible with Postgres.
Mm-hmm. Yeah, vacuum is yesterday Google. Google. I think that those who are watching the database landscape, folks, you might came across a blog post by Google. They introduced automated auto vacuum in their AlloyDB offering. AlloyDB is like Amazon Aurora, but with some additional analytical capabilities. And generally, yeah, like they use, I think, just all the reasonable things. Like they have this. Uh, they throttle the CPU usage, they throttle the memory usage. All those improvements don't sound like rocket science, but generally even Google needs to take care of this, and they are adding something to their database because auto vacuum is might be a bothering problem in many Postgres deployments. Anyway,
Yeah, even more for managed service, because when you manage your database, you know what you are doing. You know that you are loading some data differently, for example, and you can expect that. In a managed service, you need that everything is predictable, because the customer
mhm.
will change the workload and the database will adapt. You don't have a DBA that to call and tell them, oh, I'm doing something different. Can you monitor that?
Yeah. That's right. All right. Before we move forward with the highlights for the last 2 weeks, Frank, do we have any questions on LinkedIn? Anything?
No, I see only Pete who joined, and yeah, hello,
Okay,
Pete.
well, hello, Pete. Thanks for joining us. So I think that soon we need to come up with some special medal for those who have never missed any community hours episode, and I think that Pete is at least one of them. Uh, Hope you like this live stream, Pete. Okay, speaking about the highlights, let's start. I have the biggest highlight that we had there. What did we have? We had the Distributed SQL Summit last week. Okay, and a lot of announcements, a lot of technical talks, and certainly, let me share the screen. And the keynote, actually, if you folks missed that summit, then generally go to the keynote. We'll share the link with you and just watch what was introduced. And then if you're interested in any particular feature, then you can do a deep dive. For instance, like, so here as you can see that we have this Gen AI improvement. We basically introduced the beta or developer preview support for the PG vector extension that deserves a separate discussion. Also, we have the new cost-based optimizer, and Frank will talk a bit more about it in a few seconds. Also, there is a live migration from Oracle to YugabyteDB using Voyager. Also, we improved a lot our performance when you want to compare YugabyteDB to a standalone cluster, and many more improvements. Like, what was your favorite improvement, Frank?
Yeah, globally, all of them globally, the Postgres compatibility going to another level, and that covers everything. Performance, we need it also, because when you move an application, you don't want to change the code because you have some performance issue. So all those improvements help to first try an application written for Postgres, try it on Yugabyte without spending time. After, if you go to production with it, maybe you will look at the data model and do some changes, but you just want to try, see if it works. And basically, all those features are around that.
Excellent. And also we had a comment from Giovanni. Oh, Giovanni, thanks for joining us this live stream. We need to, yeah, Giovanni actually is the one who contributed the PL Python extension to Yugabyte. Is
A
that right?
major contribution, yeah.
Yeah. So like we are working on scheduling a dedicated session about this contribution with Giovanni. So stay tuned, folks. But in the meantime, that's what he is saying. What makes me most interested in YugabyteDB is the HA built in with write capabilities and its distributed nature. One database cluster for many microservices is easier in this model. Yeah, it's like it's hard to argue with this statement. And the second one is also the compatibility with Postgres. Yeah, compatibility, because we don't want to rebuild our application from scratch. Exactly. So Frank, why don't you show us your detailed article about their cost-based optimizer? And then I think as I said, probably the next following community open hours, folks, we will be scheduling dedicated demos and sessions to
Hmm.
discuss all of these capabilities in details, including the cost-based optimizer. But today, consider this as a preview from Frank.
Yeah, so basically, when I test something to see exactly how the parameters works and I want to kind of document it, I write a blog on Dev2. And because in the past, I explained how it was working without the cost-based optimizer, so without the statistics, I added that as a part two of it. So here the idea is that now we have some features where if you gather the statistics with analyze and you enable those new features, they are not enabled by default. They will in the future for sure. Then you really have a cost-based optimizer. The idea of cost-based optimizer is that there is no simple rule like if there is an index, use the index, because that depends. If you read all the rows from a table, you don't want to go through an index. You just want a full scan for that. So we have two parameters, and I've written this blog post while mainly I was investigating the second one because I knew the first one, I always used it, but I was not so familiar with the second one. And basically, there are two things because of our architecture. We plug Postgres on top of the distributed storage. And first, we use the Postgres code. So the first one is to enable the Postgres code for the cost-based optimizer. So YB enable optimizer statistics. The query planner uses the statistics that are gathered by analyze.
Mm-hmm.
And the second one is a change in the cost model because the Postgres cost model doesn't fit the distributed storage. So this enables the changes that we have done for that. And yeah, two things are
So
different.
yeah, the second one parameter,
Yeah,
obviously Postgres cost based optimizer is not aware about a distributed deployment at all. It's only living its own vacuum of their single node instance, right?
yeah,
But
I,
also
and
besides that, also there is a storage, right? Like B3
yeah,
versus LSM.
yeah, we use LSM trees, and then the cost of reads and writes are different,
Mm-hmm.
and this must be adapted to that. Also, we have many things that are different from Postgres. We don't have the vacuum. We don't have visibility maps. In Postgres, the cost will be different if it was recently vacuum or not. That's not our case. So it makes sense to come with a different cost model for different storage, of course.
Okay, yeah, I
So,
played. I played actually. I played with your demo.
mhm.
Looks neat and simple, and it's easy to follow. If you folks know the basics, right, of the optimizer, if you can read at least, if you can read the execution plan summary, then give it a try. If you have never read execution plan summary, then also give it a try because it's a very wonderful kind of journey. It's worthwhile investing your time and effort in learning. It's quick and simple, but it will pay off you a lot. So why don't we?
Usually, when I want to understand something, I want the simplest test case. So for this, only one table was sufficient, and where I generate exactly what I want to test. Here, the big difference, the most important with the cost-based optimizer is to estimate the selectivity of a predicate, knowing if your predicate will return one row or all of the rows. And then my table is just a table with a column that has 10,000 values
Mhm.
with unique values. So if I query on this value, I will get only one row and another 10,000 with all the same value. So that if I query, I'll return half of the table. And basically, in most SQL databases, if you query one row, you want to go through an index to get exactly to that row. If you query half of the table, you probably want a full scan because a full scan is more efficient. You start at the beginning, you go to the end.
Mhm.
Even if you discard 50% of the rows, it's still faster
Mhm.
than going. It's the same with a book. If you are looking for a specific word that is on a specific page on the book, you go to the index. If you are
Mm-hmm.
looking for a word where you know it will be on one page out of two, then you will just scan the book, and look at it. So basically, the
Okay.
principle are well known. Yeah.
Yeah, let's pause here because I truly want us to dedicate a separate community open hours
Mhm.
live stream to the new cost-based optimizer, and let's have our the folks who are watching us just to explore your article offline. I want them just to try and play with it because it was a nice and joyful experience to follow your demo. But one last question before we go. Uh, does it mean that we did not have, I mean, does it mean that YugabyteDB did not have any cost optimizer at all before this release?
Actually, I would say yes. Actually, we were using the cost-based optimizer of Postgres, but with specific rules, and those are those that I've put in the previous article, which are those rules, and it was really fixed. And you see that if you do an execution, an explain plan, you see that in the estimations, and you
Mm-hmm.
will see that a sequential scan always defaulted to 1000. So if there is no analyze, if you analyze the table and you enable the cost base, and before those improvements, then yeah, that's a cost base optimizer, but not with the right cost model. So basically, either you do not analyze the table and run with the rules, which is okay for typical OLTP queries, because for OLTP
Mm-hmm.
queries, you query with a key, you want to go through the index, that's simple. For more complex query, especially when you have joins, you need that the query planner estimates better the cardinalities, and then the goal is probably to enable both of them. I think they will be enabled by default soon. We also put that in preview, see how it works with existing customers, if there is something to improve on that. But I think it's also a good idea to have the choice of a rule-based optimizer, because sometimes you don't want the query planner to come with a better execution plan. You just want to use it the same.
Mm-hmm.
Plan
Mm-hmm.
stability. So
Yep. Yep.
depends on the
Exactly.
kind of application. And maybe setting it per session. Your typical OLTP queries using the rule base, but if you have some kind of reporting, then probably you want a cost base there.
Okay. So and now at least you have several options in YugabyteDB. We
Yeah.
certainly have the rule-based one and we have the cost one. We reuse what Postgres created and we also improved it by adding our own optimizer for the to consider our LSM storage in our distributed nature. Cool. Nice. So okay. Let's move forward with our next topic. So the topic that we planned and that is written in the title for this episode says distributed YugabyteDB on your machine. So let me hide this banner actually because I think it's distracting. Yeah, this way. So what does it mean? We have laptops. So like we live in the world when you can spin up your database instance in any cloud environment, get a connection endpoint, and here you go, create your application and run your experiments. But also, let's say, but uh, sometimes it might be much more reasonable and it's certainly much more cost effective to start your database on a personal machine because you already paid for this machine. I don't think that you have like some credit on it. You just have this machine, you have resources, you have CPU, you have disk, you have memory. Why don't you run your database there? And when we are talking about YugabyteDB, usually not usually, like you would be creating applications that require distributed database deployment, at least 3 nodes, which means that if you're creating your application and you want to run your application locally and you want to connect to your local multi-node database, then what are the best deployment options? And today we want to show you how to start with YugabyteDB distributed deployments on their local machine that is available to you. So I will be using my laptop produced by Apple, and we will be using the YugabyteDB tool. So this is the tool because usually when you create your deployment, you need to start a T server that basically stores the data, and processes your request. So like if you want to have a 3-node cluster, you need to have 3 T servers running on your local machine. Also, at least you need to have one YugabyteDB master on your local machine. In the production environment, at least you have 3 YugabyteDB masters that are responsible for the cluster-wide metadata, and you need to have as many as needed YugabyteDB T servers. But actually, these are different commands, right? You need to start them, you need to follow the flags, and it's a little bit, folks, I don't like that approach personally, especially for my local deployment on my local laptop. That's why YugabyteDB comes as a solution. So what YugabyteDB does, it basically you just run one command and it will start both our T server, YugabyteDB master, Postgres backend, and YugabyteDB UI. You'll see how it works in practice. It still said that this is not recommended for production, but we need to check it because based on one of our last conversation with the product management team, this notice should be removed from the website soon. Do you have any insights, Frank? When are we planning to?
I don't, but I think it's also quite safe to say that because it doesn't change how Yugabyte works. It just changes how to deploy it and automate something. So yeah.
But anyway, if you want just to run your multi-node and distributed YugabyteDB cluster on a local machine during the development, just use this tool. It's simple, right? It's damn simple. So let's do this. How do we move forward? First, it's shipped with the YugabyteDB distribution, which means that you need to download one of the latest YugabyteDB releases. Let's just start from the beginning. So I'm on macOS. That's why I have this option. Let me just copy the first 2 lines that download the release and unzip it. So that's my terminal. I'm located in the downloads folder of my laptop, and I'm doing this. I'm doing nothing. It did not copy anything. So let's do once again. Copy. Okay, and that's the latest release that has all of those improvements that Frank that we discussed, including the new cost-based optimizer. So I'm inside, you can see it here, and I need to go to the bin directory, okay? So I see that we have a few questions. Do you want me to pause right now? Okay, we have...
Yeah, it's P2 mentions that in the YB example page, we could add Docker or Kubernetes, how to run YugabyteD with Docker and Kubernetes. That's also something we have also improved a bit YugabyteD so that it's easy to work on Yugabyte and on Docker, and there are a few improvements that will come also with that. Yeah.
Okay, cool. All right. So then let's do this. So what we want to do, generally, as I said, what will happen, let's create this temp file. When you start, when you use YugabyteDB to start one instance, what YugabyteDB will do? First, it will start a YB T server, right? That is responsible for the data and query execution. That's going to be a separate process. All this is a separate process. Then it will also start the YB master instance. That is basically keeps your cluster-wide metadata. And also what it kept, like we use it for the execution of the DDL statements, right, Frank? Do DDL statements go to the master?
The DDL, the catalog changes go to the master.
Okay.
Yeah.
Catalog.
The
Catalog
DDL
changes.
are processed on the T server, but the metadata is stored on the master. Yeah.
Wonderful. And also when you start YB master, the YB master starts the Postgres backend, right? That's what happens. And this is because we use Postgres, we are built on Postgres, and we reuse it. And Postgres, as you know, runs as a separate process. And also, as you will see, this single YugabyteDB start command will also create a Yugabyte UI. Probably it's called this way. This is the new user interface that we discussed in the previous episodes. So generally, when you will execute we will execute command like this, yugabytd start blah blah blah, and this command will start the following processes on your machine. Generally, it's simple, and this is why it simplifies the user experience. So we don't want to save it; we just cancel it. Okay, now let's do this. I'm going to start using YugabyteDB. start command, and I want to this node, the first node, to listen on this address, standard one. And you can provide, you cannot provide the base dir. I usually provide the base dir. That's the directory when the configuration for this node and the data for this node is going to be located on your laptop. I provide because I'm going to start a multi-node cluster. So generally, I created this directory in my home folder, and then when I start node number one, I'm telling this node number one to store all the data, all the information, all the configuration under this directory. So this is what I would advise folks you doing as well. So let's start the first node. It depends on your operating system. On macOS, usually for me, it takes 10 plus seconds to start the first node. The next nodes will join the cluster much faster. But that's my macOS machine. It takes time. Overall, we are up and running. You have some of the connection endpoints, like this is if you want to connect from the application. You have the UI. This one, I think it needs to be updated to the new port number, to the new UI. So you also can always check this information this way. You can use YugabyteDB tool, status command, and also don't forget to provide a home dir for your node. If you change this default home dir, I changed it because I'm going to run a multi-node cluster. And the status command is going to return the same information. It's just a quick and dirty. You remember I was talking that this single YugabyteDB start command would spin up several processes on your operating system. You can check this with PSaux. Let's do it this grep yugabyte. So here as you'll see, all right, what we have. We have yugabyte. Yeah, it doesn't fit my screen. Let's do this way. We have YugabyteDB master running. Then we have YugabyteDB server running. Okay. Then we also have Postgres backend running.
So the Postgres backend is a child of the YBT server.
Exactly. And also somewhere here we should have their YugabyteDB UI. Yeah, but it's hard to see. Probably
If
if I
it was
do.
started, should be there, yeah. And also yugabyted is a process that is there to restart if something fails. Also
Yeah.
detective.
Yeah, it's somewhere here. I don't just remember the name of this process, but it's running. So let's do this right now. If you have the first one instance, just one simple command. You download it, you start it. Oh, this was updated, interestingly. So that's the port and that's the address. So that's my node. That's the new UI. You have this database node. It runs in this default data center number one, rack number one, whenever they are. There is no any data yet. We need to create some database. But first, we are talking about distributed databases, right? I want to have a multi-node deployment. So what do I do with YugabyteDB? It's simple. Let's do this. Again, we are using yugabytd command. We are starting another node. This node is gonna listen on a new, what I need to show you folks. This is important to show. I need to go to the docs. It was the wrong direction. If you're running on macOS, and that's not a problem for other users, you might need to do this. Where is that recommendation? You need to add you would need to start your database instance on a different port number. Yeah, I lost it here, but let me show you my
because the port is already used on macOS.
No, I mean like this one. You need to create these aliases. Because I will be starting my second node on 127.0.0.2 interface, and the third node will be listening on this IP address, on this interface. And you need to execute this sudo ifconfig command on macOS. Otherwise, you will not be able to start. Let's try. Probably it already works. Advertise address, if I have created it before, 127.0.0.2, and it will join the first node, and the first node is listening on this address, right? And also we need to provide the home dir for the node number two. Just do this, just the same directory but different subdirectory. So let's see. Okay, looks like yes. Looks like I already pre-created this interface. But if you are starting from scratch on macOS, don't forget to do this. For the second node, you need to have a dedicated network interface, and for the third one as well. In Linux, you don't need to do that, and probably you don't need to do that on Windows, but that's required on macOS. Okay, the second node is running. Excellent. Let's quickly spin up the third one. Again, just change this one. Its data and configuration is going to be in this folder, and it will join the same first node, but its IP address, the IP address of the third node is going to end with 3. Waiting. Okay, so right now we should have this 3-node cluster. How can we check it? Again, you can use PSQL. You can use your favorite tool. You can use anything that is the most convenient for you to connect to your database. But you can also continue using yugabyted. So yugabytedb comes with the connect command. You can say that connect using YSQL interface and connect to the cluster. And I already have this cluster running locally, and I just need to tell, all right, connect to to this node. So this is the base dir for node number 1, and just find all the connectivity related settings in this dir and get connected. Okay, I'm in. I have connected to the cluster. Let's check whether we are really connected to that cluster. We have this handy YB servers function. Select from, right? I always forget to put from after the star. Yeah, we have this cluster running. All is good. And it was easy to do with the yugabytedb tool. So generally, what we did, we used yugabytedb start to create the cluster. Then we used yugabytedb start and join parameter to add additional nodes to the cluster. And you can use yugabytedb connect to just open the YSQL connection to the database and run your SQL. If you jump back to the interface, let's refresh it. Where are my nodes? I have 3 nodes. Cool. And you can see that the data is already distributed. Those are system tables. But we don't have any custom data. What's cool about yugabytedb is that it has a special demo command. Let's try it out. So generally what that command does, it will pre-create the Northwind sample data set schema and will load some data. So if you just want to play with yugabytedb, you don't want any data set handy, you don't want to come up with some custom tables, just start your cluster and then let's try to do this demo. We are using yugabytedb demo connect, and then again you need to provide a path to the base dir of one of your cluster nodes. It can be node number 1, it can be node number 2, it doesn't matter, right? So let's check. Cool. Seems like it connected. Okay, successfully loaded. And also once loaded, you can see that it opened the connection using YSQL SH. So I'm already in. I have these tables. We can select, select from products. Limit 1. Okay, there is some data. Nice. Cool. So it took us how many, like 6 or 8 minutes, right, to download yugabytedb, to start a multi-node cluster. This multi-node cluster is running and it's ready for our experiments. You loaded it with the data. So that's the database. Let's refresh the database. I should see the, come on.
What is very nice is that you don't have to think in advance about the final deployment. You start a node and then you have a single node cluster, and then you start a second one and a third one, and then it changes to be replication factor 3. You don't have to. If you start yourself the master and the T server, you need to know exactly what will be the addresses of the other masters, the replication factor you want. So it's easier to
And
start.
yeah, and this is important, right? Because as what you just said, my friend. Yeah, that was my beginning, right? Just going back. That was my beginning. I started one node cluster. I just provided this advertised address. And by default, if your plan, folks, if your plan is just to start a single node instance on your developer laptop, then you don't even need to provide these two parameters. You just don't need it. You just need to do this. But again, I provided these two parameters because I want to start a multi-node cluster and I want to know like what IP address each node is listening on and where its base directory is located. So, but this, again, these two are optional. That was the beginning, right? And then what you've just said, when I decided to scale the cluster, this is how I joined. That's my second node. I just changed the advertised address. That's going to be the IP address of the second node, and it just need to join this cluster using this connection endpoint. And the same was for the third node. So it's nice. It's simple. I like it as a developer. I like it. So
I use
next,
it a lot also in Docker, and then I don't have to care about those IP addresses because each Docker container has one. I just create a Docker network and then start the containers in the same network.
agree. Docker actually is also one of my before because YugabyteDB is being YugabyteD. I don't think the name is the best.
I
YugabyteD tool.
always I always made the same mistake. Yeah, YugabyteD is the daemon that starts
Yeah,
YugabyteDB.
it's like it's a little bit confusing. Yeah, we need to do something about that. But nevertheless, yeah, like, I think that the YugabyteD tool has been it goes through improvements with every release. And when I tried it for the first time, let's say probably a year ago, I was not that happy about it. And Docker became my default choice. Uh, but with Docker, like the thing is, if you run a multi-node YugabyteDB cluster in Docker and you create some, let's say, Java application or JavaScript application, then you also need to deploy this application in Docker if you
Yeah.
want, let's say, to test some load balancing or fault tolerance. And sometimes I'm lazy to do that. That's why today, as long as YugabyteD, I think it's already production ready. Uh, I can just start this on my host operating system and I can run my application as a separate process and it just can easily connect while I'm developing application. I don't need to run anything in Docker. So it's again different options, but also something for consideration. Now, what also happens is that take a look at this cluster, at the cluster region and zone configuration. It's located in the default data center one and rack number one. This is what we specify if you don't provide us with any details. But sometimes when you create your cluster, you can you might want to create a multi-region cluster, right, in specific locations. Let's say in AWS West Coast and AWS East Coast and in the central zone. You might want to have a multi-zone cluster, which means that when you start a multi-zone cluster or multi-region cluster or geo-partition cluster, then you need to provide the actual names of your regions or like something standardized. How do you do this with YugabyteDB? Because it's all possible. YugabyteD start command has what it has. It has the special to flex cloud location. This is where you can change their region name and cloud provider name and zone name. Because if, for instance, if you're running your applications and your database in AWS, then this is what you would adjust. And fault tolerance determines the fault tolerance that will be applied to your data policy, data distribution. So it can be none, but it's like it's not a production use case. It can be zone level, region level, or hybrid if you're running like across multiple regions. So let's see how to create a multi-region cluster, a multi-region geo-partition cluster using YugabyteDB in our custom regions. Okay. It's also straightforward because when you're creating your application, sometimes you need to know that, all right, I'm creating a geo-partitioned application, which means that I need to have a geo-partitioned cluster running on my local developer laptop. Then how do I use YugabyteDB, YugabyteD tool to start a geo-partition cluster in these specific regions, and then just keep coding my application. So that's the use case. First, I want to start the existing cluster. And actually, that's a good opportunity for us to see how do you stop or pause your cluster with YugabyteD tool. It's simple. you do yugabytd, and there is the stop command, and you just need to also provide the base dir. So the stop command basically just stops your instance. The instance becomes unavailable. So right now what happened, if I go to this UI, it's no longer response because I stopped the first node, but I think that the second node and the third node, they're still running. They're just running on a different interface. You can see that I connected to the second node UI, and they're saying, yeah, the first node is down, but nevertheless, that's how you can stop your node. Also, if you just if you're done with this cluster configuration or your application is ready and you're moving to some real production environment for further testing, you can destroy it, remove all the configuration, all the data by executing yugabytd destroy command. Okay, and it's deleted. And now I want to delete the entire cluster, which means that I want to destroy node number 2 and node number 3. When you destroy, you obviously stop and then destroy the node. So right now, if I jump back here, I don't see anything. Okay, it's obvious. Now, the goal is to start a geo-partition cluster across, let's say you're creating this global geo-partitioned application that has customers in the United States, Europe, and Australia, which means that you want to pin their data to specific data centers in the United States, let's say in Germany and in Australia. How do we do that? Again, let's start the first node, yugabytd, and you do start. You still need to provide their advertised address, right? Let's say that for your development machine, your first node is going to be running on the same interface. And then let's have the same home dir. And after that, you need to provide this cloud location. So let's say that you are planning to deploy this application in AWS, and this node needs to run in the United States East 4 region, and zone is going to be zone A. Okay. And also you're saying that the fault tolerance needs to be region, which means that at least one copy of the data needs to be located in every region. So I missed something. yugabyteDB start advertise cloud location. Probably, that's the case. I need to change this symbol. Okay, we are starting this node. And while we are starting, let's answer a few questions. We have a question from Zayan.
We have a few questions.
Yeah, can we have multi-AZ scenarios over on-premises, key 8 clusters running in private cloud connected via Submariner or some other means? I have not used Submariner. Have you, Frank?
I don't. I think the answer is yes. Then we need to see how to configure that. But basically, when you start a node, you can you start it with a private IP, and you can add a public IP if the address is different on the global network. So basically, mostly everything is possible. I'm not sure that it's all possible with yugabytedb when the configuration is too complex. But basically, yeah, we can have nodes on premises on multiple Kubernetes clusters. Yeah.
Mm-hmm. Yeah, I think that I think that probably I remember this question from the from Slack. Probably Zayan have already asked it there. But let us know, like, if you still have any troubles with it, because technically I don't see any limitation. Because yes, at least answering the first part, you certainly can deploy yugabytedb cluster in your private Kubernetes environment, in your private cloud across multiple availability zones. And then if you need to use Submariner, give it a try. And yeah, we have a clarification just to explore the feature. Multi-cluster service, yeah, like we use, I know that you can use, there is a blog post. If you have, let's say, several standalone Kubernetes clusters, right, and you have yugabytedb running in those clusters, then it's also should be possible. And I think that we should have some content related to this, not for Submariner, but for something else. But yeah, start exploring, and pin us on Slack if you have any trouble. So if anything is not clear, but that's what I would do.
Yeah. We have also another question from Samir on LinkedIn.
Oh yeah, let me
So
just first, yeah, while you're copying that question, we have question from Eshwar. If you don't mind here, how many nodes we can load at a time, and if we need to load some particular number of nodes so that we can, what we can do. I mean, you can start as many nodes as you like. You can stop the nodes, you can take them down, you can add the nodes. It's like you can scale out whenever you need, and you can scale in just back also as necessary. It's up to you. It's based on your load. Just monitor the performance metrics of your application, the load metrics of your application if necessary. If you know that you need to add more capacity or more CPUs, just provision an extra node.
the limit is only on the minimum. If you have replication factor of 3, you need at least 3 nodes because you want replication on different nodes. But there is no maximum. The maximum will just depend on the need to scale. If you have the same number of nodes as the replication factor, that means that the all data will be on each node. When you start to add more nodes than the replication factor, there are some data that is not on all nodes because the tablets are replicated elsewhere. So if you have, say, 100 of nodes, each node has only a small part of the database, but you still have 3 replicas across all of them.
And we have the question from Samir. If you have to run YugabyteD on AWS, what options do you have as it's not a managed service? If you are looking for the managed service, man, that's probably the easiest question to answer. Just go to cloud at yugabytedb.com, create an account, and that's my personal account.
Yeah, let's just precise. There is no AWS managed service for Yugabyte like they have in RDS other databases, but we as a Yugabyte company manage on AWS. So there is a possibility of a managed service. It is not managed by AWS people. It's managed by Yugabyte, but still running on the AWS infrastructure.
Yeah,
And
yeah, exactly.
if you don't want a managed service, means if you want more control on your database, but also more things to do, then you can run it as you want on EC2 instances, on containers, on Kubernetes, on EKS. Everything is possible. Basically, anything that runs Linux can run a Yugabyte DB node.
Mm-hmm. No, nice, nice. You have the options. Okay, so let's quickly jump back to the demo. Uh, so to remind you, we were starting a node in this cloud location on the local machine, US East for Zone A. It said that it's running. Let me go to the UI. Okay, the node is running. If you go here, you can see that's your zone and that's your region, region US East 4, zone number A. So now let me do this. I just need to be precise about these zone names because I want to run some demo. Um, Next, let's say I'm studying a node in a different region. The second region, I want to be it in the second node. Let's start with the second node. The second node is going to have this IP address. And similar as before, it needs to join the rest of the cluster. And this is the first node. I need to change on my local laptop the base dir for this node. And I want to change its cloud region. It's still going to be AWS for my application use case. But now it's going to be Europe, West 3, let's say Zone B. Starting the second node. And let's also start the third one. The third one will be on this IP address. It will join this one. Its base dir needs to be different, not number 3. And I want to change the region name. This node, according to our application design and architecture, will be in Australia Southeast 1. So it's like we just decided that this is what needs to be, this is how the deployment will look like in production, right? In your real environment, in your real cloud environment. And we just want to create a similar cluster with the same region names, with the same configuration on our local developer laptop using YugabyteDB so that we can move forward with the development. Let's refresh the screen. Okay, we've got these 3 nodes, and each node is running in different cloud location and cloud regions: United States data, Europe data, and Australia. Also, once you deployed your nodes, and if you're planning to deal with a geo-partitioned use case, what you also need to do is to execute this configure command, data placement. So this data placement command says yugabyteDB that, all right, so the data, the fault tolerance is region, which means that you need to make sure that the data is distributed, at least every copy of each record is located in every region. But then it's also needed if you run a distributed a geo-partitioned cluster. So let's do this yugabyteD configure data placement, and we know fault tolerance is region, and at least we need to provide a path to the cluster. I'm telling like change it for the cluster where this node is running. So that's node number 1. Okay, we changed configuration successful. Primary data placement is geo redundant. Let's like geo distribution. And finally, let's run some experiment. I have what I have. I have in my downloads folder a couple of scripts. I have these table spaces. So if you're using a geo-partition cluster, I'm going to create a table space, United States, and it's going to be like pinned to the region, to this region, United States East 4, meaning that all the, like, if you are going to put any partitions into this table space, then the data will end up on in this region, in the nodes that are deployed in this region, right? And then I'm creating similar table spaces, but for Europe and for Australia. Okay. How do we do this? I need to, once I create these table spaces, also after that I will create my sample table. And the sample table is profile. It's profile table. I'm going to partition this table by the city column. And if let's say the city column has New York as the value, then the data will go into the US table space. And the US table space will be located on the nodes that are running in the United States, right? If let's say the city is Berlin, then the data will be in the European table space, in the European database nodes, and the same is applies to Australia. Okay, so now let's use yugabyteD connect once again. Let's connect to this cluster, and then you can load the script this way. The same commands that you use with Postgres. Something has broken. Users, the Magda downloads table spaces. We created table spaces, and then we are creating partitions. Okay, so now let's take a look at the structure. You have this profile table, and if you're familiar with the partitions in Postgres and geo-partition in yugabyteDB, you've got these partition tables, like that belong to the main one. You can also look at more details using this command, profile. That's the profile table, and that table is split into 3 subtables or 3 partitions. And the data will go to one of these partitions depending on the value of the city column. Okay, makes sense? So this is how you can quickly start a geo-partition cluster across multiple regions using yugabyteD on your personal laptop if it's required for your application. That's the point. If just to run a simple test, let's insert the first record just to make sure that everything works as planned. Insert into profile values. Let's say we have user number ID 1. It's Mark, and Mark lives in Berlin. Okay. Now, if you do this explain analyze to return the record for Mark, where let's say ID is 1 and city is Berlin, you'll see where the data is queried from. the data, this is the index scan, and the data is queried from the profile Europe table. So even though you are querying the profile table, YugabyteDB is smart enough that the data, as long as you provided this city column, the data is queried from the specific partition. You don't need to scan all the tables. You don't need to scan all the partitions. And finally, just to confirm that's the case, as you remember, you can always query those partitions directly, just to make sure that the data is pinned to the right places, to the right nodes. We don't have any data in the profile USA because Mark lives in Berlin. It needs to be in Europe, which means that I hope to find it in this partition. Yes, Mark is in Europe, and this partition is pinned to the database node that is in Europe, in this region. So this is what we configured with YugabyteDB later. And just to make sure that there is no any copy of this data is in Australia, no any data. So job done. So this is how you can use YugabyteDB to start a cluster with your custom regions that will align with your production environment. And this is actually also how you can quickly create a multi-region cluster for your geo-partitioned application if necessary. Cool, fast, right? Easy. And to finish up on the YugabyteDB, just explore the docs. There are not so many commands because the tool is very straightforward to use. You can always check the version status, destroy stuff, and third command is for the cases when you want to create a secured connection. If you want just to run this in a secured environment. Okay.
Yeah, the goal is really to have commands that fit what the user wants to do. Where when you start a YB master, YB T server, you have all the possibilities, and there are many, and then it may be, yeah, the quick start is more difficult with all the possibilities. So YugabyteD really focus on the commands that you want to test, the kind of cluster you want to test.
Mm-hmm. And I personally, I liked how the tool evolved because every time when we are planning something, we have to prepare and like even comparing the latest YugabyteD release to the one that I played with a couple of months ago, it's already there is a big difference. At least I feel this on my Mac OS machine, so
Mm.
it works. It's stable, and I can always easily start the cluster, stop the cluster, delete, and start with a different configuration. It's all straightforward. So enjoy, folks, and leverage it. If you have any feedback, if you have any issues, or if you have any, uh, if you have, if you want to suggest any improvements to the tool, just go to us. You can find us in the Slack community, and
No, it's made to be easy. So even if it works, but someone has an idea that it could be easier differently, then yeah, good to have this feedback. Yeah.
yeah, exactly. So that's all I wanted to show when it comes to YugabyteD. And we actually are going to, the stream is going to end in 2 minutes. So any questions, any other, if you want us to address anything, we are happy to do so.
I'm checking the questions. I see no more questions on LinkedIn.
Yep. And thank you, Eshwar, for coming and staying with us. So I think that Eshwar is similar to Pete. Eshwar and Pete, I see them both coming to each of our live stream episodes. So thanks a lot to you, Pete and Eshwar, for being with us on the line.
And the questions also help us. It's a kind of also of getting feedback. We need to have feedback from users, and that's also why it is open source. And we have some feedback in the forum, in Slack, but direct feedback like this, when we discuss some feature, the ideas that come, that's really interesting. Yeah.
Absolutely. Nothing to add. Nothing to add to your conclusion. All right, then. All right, my friends. Thanks for joining, and we'll see you in 2 weeks. That's going to be our 10th episode. And we are planning the next topic. Hopefully, we'll get Giovanni showing and talking about PL Python contribution, or it can be something else, something from those freshly baked and introduced features in their latest release that were discussed during the keynote of DSS Summit. So we have a huge backlog. Yeah, and thanks to you, Zan. Thanks for
Thanks
coming.
everybody.
Bye.
Bye.